Alright, this video is going to include information on polyatomic ions, covalent bonds, and ionic bonds. Oops. So, the first one is about polyatomic ions. Those are on the back of your periodic table on the very bottom. Polyatomic ions are, let's break down the word. Poly means many, atomic means atoms, and ions we know are charged particles. So in a polyatomic ion, it's many atoms that are stuck together and they all have a charge together. But I'm going to make it a little more specific. Many atoms covalently bonded that carry a charge. So that word covalently is really important because it tells us what kind of bonds to make on things. Let's think about an easy polyatomic ion that we could do. Something like NO2 1 minus. So I'm going to put N in the middle and O on the outside. This is called nitrate. It's on the back of your periodic table. N comes with 5 valence electrons. O comes with 6. We want to put the single dots in the middle. Single electrons in the middle. That way we can make covalent bonds really easy. Covalent bonds are these sharing electron bonds. They're the line bonds. And then I'm going to see it, well, I'm going to need a double bond here. Between this and this electron, we'll double bond it. I know it looks kind of sloppy, you'd want to bring it in. And then last but not least, I can see that I've got this one electron hanging out right here. He needs a partner. The 1 minus suggests that you can add an electron. And that electron we're going to show as a triangle. And I'm going to put that triangle right there. Once you put in a triangle, you've got to put in brackets 1 minus charge. What this triangle means is that you've gained an electron from somebody. Now in this case I didn't specify who it came from, but I could say that this is sodium nitrate, NaNO2. Sodium nitrate, sodium is a 1 plus and nitrate's a 1 minus, so together they make a balanced compound and a neutral charge. So to finish off this compound, if I said it was sodium nitrate, I would have a sodium 1 plus ion over here, and that's a 1 plus, and the nitrate ion right next to it, and that would make the ionic bond. So the attraction between the sodium and the nitrate, that's the ionic part, and these sharing electron bonds are the covalent bonds. Since we just did an ionic compound, let's go over to this far side to ionic bonds. Ionic bonds are made of metals plus nonmetals. So anytime you've got a metal, you've got to think of an ionic bond. Calcium chloride might be one we could do. Calcium is Ca with the 2 plus. Now, I don't have any dots around it because it's a 2 plus. It gave up its valence electron, so it has none. Chlorine came with 6 valence electrons, but gained 1. That's how it had a 1 minus charge. It gained that 1 triangle from calcium. But there happen to be 2 chlorines, so I got to put a big 2 out front. If you put a little 2 right here, that suggests that the 2 chlorines are stuck together, but they're really not. The 2 chlorines are really like, remember when we drew those circles? 2 chlorines not stuck together. So that's why we want the 2 out front. It just says there's 2 of those circles. So that's what an ionic bond looks like. Last but not least, we have a coordinate covalent bond over here. I'm going to give you the definition to that. When both electrons in a bond come from the same atom. Here's going to be a classic example. Phosphate. Phosphate is a polyatomic ion. It is PO4 3 minus. I'm going to put in my Lewis dot structures, put in my valence electrons. Phosphorus has 5. Oxygen, there's one right down here, has 6. Start hooking up the little dots as easy as I can. Boop, boop, boop. Looking pretty good so far, but you see I've got to hook up that P to that top O. But it's kind of weird because I've got 2 electrons down here by the P and 1 electron by the oxygen. So how do you hook them up? You might be thinking, well, just kind of do this. Well, if you do that, then you just divorced the electrons that are on the top of the phosphorus up there, and that's not a legal thing to do, because they're hooked together. So you can't do that. So you've got to figure something else out, and that's when we do a coordinate covalent bond. That's when you circle up the electrons, draw an arrow that covers up that electron, and then move that electron I just covered up to where he's needed, what happens to be over here on this side. So, taking a look at our coordinate covalent bond, It is when both electrons in a bond come from the same atom. Both electrons in that bond came from the phosphorus. In a normal bond, you get one electron from one guy, one electron from the other guy. That's a covalent bond. But in a coordinate covalent, both electrons come from the same atom. To finish up this drawing, I need 3 triangles. 1, 2, 3. And I just so happen to have lonely dots there. Put a bracket around it with a 3 minus. Now, how do you know when to do a coordinate covalent bond? The most classic time you're going to ever need to do a coordinate covalent bond is when you've got this 3 situation, like we'll do sulfur, trying to hook up with a, I don't know, phosphorus. Why not? Whenever you see a spot where you've got like 3 electrons in one thing and you're wondering what to do, that's when you want to think of coordinate covalent bond. So you circle the electrons, cover it up that dot, and push it to the side wherever it's needed, by a single lonely guy, of course. So that's when you know you need a coordinate covalent bond. I hope that helps. These were the notes that we took on day 2. And from there, good luck. Come see me with questions.